Hello and welcome to the C programming lecture on logical operators. Logical operators extend our ability to create complex Boolean expressions. We can use things such as and, or not. So you can see the symbols here. The and statement is the double ampersand sign, the or statement is the double pipe sign, and the not statement is the exclamation point. Now, we've talked about some of these things in the sense of using them for bitwise operations, but now we can combine two different Boolean expressions using these various different and or statements, or we can invert one by using the not statement. So these logical operators you can think of as short circuit processes for Boolean expression evaluation, meaning if you have an and statement, it will evaluate one of them, and if it's not true, it will no longer evaluate the second because it already has evaluated the first to be false when you expected it to be true. So in that case, you can think of something as short-circuiting process. So the left or right side will only be evaluated when a particular condition will be true. So this again is called short-circuiting. Here's an example of the logical operators. We have x equal to 101, and we can go ahead and write a complex Boolean expression using the and sign. We say x is greater than 10 and x is divisible by 100, or x modulus 100, and the remainder should be equal to 1. So this statement, we have two Boolean conditions here, and we want to check that they are both true. So you can go ahead and go down the list and kind of see which ones make the most sense, but we can see here whether or not, for instance, this line on line 22, we invert this particular condition. So it would be false, so x is less than 100. So this line here is not true because 101 is larger, is greater than 100. So this condition returns false, and then our not statement inverts it, which says here line 4 should print. So, and we see that out here. So what we've seen so far is the ability to group Boolean expressions. We can make more complex Boolean expressions by using these logical operators, so by using and, or, nots, and things of that nature. So recall that in C, operator precedence does matter. Therefore, it's typically better just to be explicit about the intentions of a piece of code. So just using parentheses where you want the evaluation to occur rather than relying on the operator precedence, because it's just more explicit what you expect. Okay, so let's go ahead and wrap up this lecture. Logical operators extend the programmer's ability to create complex Boolean expressions. So we can just do things like, if A is true and B is true, continue down this path. Or you can do some combination of that. So here's something for you to think about. Do you think you can recreate some of our examples using some of the if, else, and else statements that we've learned about in the prior lecture, using these and statements? Okay, welcome back to the lecture on logical operators. So in our prior lecture, we went over the FizzBuzz problem. So basically, if a number is divisible by 3 and 5, print out the word FizzBuzz. If it's only divisible by 5, print out buzz. If it's only divisible by 3, just print out fizz. So let's go ahead and use some of these things that we've learned using the logical operators, so and, or, not, to rework this problem. So what we're going to do is we're going to go ahead and get rid of this case here, which was just returning whether it's even or odd because we don't need it anymore. And what we can do is let's rewrite this logic using an and statement. So what we can simply say here is we can test whether or not x is evenly divisible by 3. And let's think about that statement that we said again. We said and. So and x is evenly divisible by 5. So we're checking to see if it's both divisible by 3 and divisible by 5. And what we'll do is we'll print out fizzbuzz. Now, once that has tested whether or not it's evenly divisible by both of these, if it is not, we need another case. So we need to have an else if, and we basically just want to check whether or not it's divisible by one or the other. So we can say else if it's only evenly divisible by 3, then we want to print fizz. And we want another else if statement here, and we just need to change this to a 5. So in some sense, it cleaned up the code a bit, I guess, but you know, it's just a different way of looking at it. You don't really have to think of it as cleaning up things, but really there's nothing wrong with the code that we had previously. This is just another way of thinking about it. So let's go ahead and compile this program to make sure it's going to work. Well, I need to cd into our cdev directory and then compile. And we see that it just returns fizz, which is what we're expecting. Now let's try a different number. Let's try 15. Fizzbuzz, exactly what we expected. Again, although it looks a little more condensed, it certainly doesn't have any nested ifs. Some people have a particular preference as how they like to have things structured inside of their code, but personally, if the logic is the same and you basically get the same thing, sometimes it's better to do things one way versus another because of X, Y, and Z reason. So you're not necessarily wrong if you did it the other way or if you do it this way, as long as the expected output is correct. Now, whether or not one runs faster than the other, that's a completely different question. So anyway, just keep in mind right now, we're just worried about the logic of the program and making sure that the logic is what we want, what we expect. Again, here's fizzbuzz. Let's go ahead and just do one more test here. Let's do 10. GCC, out, buzz. Yep, so exactly what we expect. And this is just the program rewritten using our a logical operator and. And again, we can use things like and or to help us figure out whether or not certain things certain things exist, or if particular conditions need to execute. So for instance, let's say in this case, when we think about it, since this is an and statement, so it requires both sides to be true. But this process should short circuit because it should evaluate this left side first, and this left side will possibly evaluate to false, or depending on our x value, and then it will fall out. And it's vice versa. Same thing can happen over here. If we have a value that this doesn't evaluate, that it doesn't believe to evaluate to equal to 0, then it should short circuit this process. You know, you're supposed to place your statement, your case, whatever case I believe that you want to have you believe to evaluate more frequently on one side of the parentheses in order for it to you know, quote unquote short circuit the process. Great, thanks for joining me on this, and I hope you learned something about the logical operators.